Hi guys, welcome back to another episode of Pollys Introduction to Computer Networks. Alright, so let's check out the announcements this week. Let's just skip the first two bullets. Reminder, the assignments this week. Hi Elu. Yeah, hi guys. Yeah, so the assignments during this week will be PA3. I have already graded many of you guys' PA3. That's great. And I see that some of the teams have completed PA4 as well. That's even better. All right. Speaking of PA4, next week we do have the first exam. Okay. So PA4 is due the week after next week. Okay. And PA4 is also not that trivial, much like PA3. PA3 is probably the hardest, but after you've worked on PA3, PA4 will be slightly easier. Okay. Hi. I hope that you all enjoy the long weekend. All right, and we do have 3 quizzes due this week. Okay, good. And yeah, exam 1 is coming next week. Okay. And if you click on the channel, or if you go to the channel list on the left, you will see that under the exam category, there is exam 1. Okay, so you do want to read through the instruction so that you are better prepared. So we know the date, the time of the exam. And you see again, the exam is going to be in a Google form. And you might want to work on the older exams also in Google Forms, so to get the feeling that how much time it takes to answer some of the questions. And tomorrow, okay, because we also need to have a Google Meet session running at the same time, so Polly can record to ensure fairness to some degree. Okay, so each of you will need to join this Google Meet session. That means you need to have a working camera. Okay. And of course, a good stable internet connectivity so that you can fill the Google form and you can upload the video, okay, smoothly, so that we can all see you. All right. And to ensure things will work on the date of exam, we'll have a 10-minute, okay, test run session tomorrow. Oh, yeah, thank you. Okay. Tomorrow, after the lecture, okay, before lunch, there's going to be a 10-minute test run session. So you guys can all call in to this Google Meet session here to make sure that your camera is going to work. Okay. And so tomorrow you might want to go to a place where you plan to take the exam, so you can test the internet connectivity out there as well. And yeah, so this, I'm sorry that sometimes Polly needs to be wordy because usually we do something, there's a lot of reasons behind the thing we do. And Polly does prefer that I explain why we do something. It's just because that I'm a person who likes to know exactly why I'm doing this or that. Okay. Otherwise, I felt that I might be doing things wrong. You see? If you don't know why, it's risky, isn't it? So I try to provide the reasons why we do need to have this Google Meet session, because you guys will be evaluated. Okay. And in order to ensure fairness, and why is fairness important? Because if it's no longer fair, people stop trying. It's, as simple as that. Why do we need to work harder? Now you understand. Okay, and by the way, the exam again is super long. It's going to be longer than the time it requires to complete. So it's the time it requires to complete the exam is going to be longer than the exam duration. Okay. So if you cannot complete the exam, that is normal. But you see that it will still be fair. So the trick here is that now you know there's a time limit and you won't be able to complete all. You want to start from the problem sets that you are more confident, or those that will take less time to begin with. So taking such an exam, you want to think it through, how you use the time during the exam. And so you see it's important that you exercise with the older exams. You will see a variety of problem sets, including the programming assignment problem sets. Okay, so there will be questions in the exam that test your PA skills, your programming golden skills. Okay. Something that I want to emphasize is this: the Google form. Okay, filling it out. Okay. It might get a little bit tricky when the atmosphere is a little bit intense. You see that after you hit submit, there's going to be some CAPTCHA tests. And some of these Google CAPTCHA tests can be complicated, and you might need to do it a couple times in order to get it through. Okay. So you do want to submit, for example, midpoint of the exam, okay, and as it's close to the end of the exam, you might want to also submit a couple more times to ensure that those the answers you feel safe, okay, are uploaded to the Google server, okay, and those you are not quite sure, you need more time to kind of debate within yourself, then you can leave it to the last. So yeah, it is a little bit tricky. So you want to upload your solution a few more times to ensure that the answers you've provided in between the two uploads are indeed committed or stored at the server. Okay, so make sure that you do that midpoint of the exam or right at the beginning of the exam. How about that? Okay, and there's a late penalty. So when pollys say, hey, we have 10 minutes left, make sure that you do the last upload, because if it's late, within 1 minute, you get 12 points deducted. And that for an exam is a heavy penalty. All right. So this is again to ensure fairness. We will probably allow a few seconds, grace periods, but you see that it's not, your last submission, if you don't do it early, it's not a sure thing. And you still have this uncertainty whether you're within the grace period, isn't it? So when pollys say 10 minutes left, do the last upload and close all the files that you are editing on the PA workstation. So we are also taking the time stamps on the code, that you are generating for the exam as well. So there'll be questions challenging the PAs. Okay, so make sure that you're familiar with the syntax, that you've learned. Practice a few more times. And if your PAs are done by your teammates, make sure that you do it once at least. And the exam scope, according to the progress, is very likely just these. Chapter 1, all the way to chapter 1.5. Chapter 2, all the way to chapter 2.5. And for the PA, the scope will be within 1, 2, 3, the first 3 PAs. All right, so I see that there are students asking questions about the exams. Yeah, you could use one machine to do the Google form, the other machine to do the camera, to join the Google Meet session. All right, good. So I guess the announcement today is a little bit long, but it's necessary to prepare you for the exam. So join me tomorrow during that 10-minute test run so you can be comfortable. During the day of the exam, you don't need to worry about the technical issues, taking the exams. And so you can fully concentrate on answering those problems, on the exam. All right, so that's the exam. There's a question from Sylvain. Are we allowed to look at our notes during the exam? Yes, you are. The exam is open web, but you are not allowed to exchange answers or your knowledge with your classmates. Okay. All right. So I mean, the point of having the exam so long. What about ChatGPT? Be my guest. Try ChatGPT. My experiences in the past was this: hey, you're not the first student trying to use ChatGPT. I considered it as a tool. Hey, you guys can also do Google search, right? The thing is that if you don't ask the question quite right, the answer coming from ChatGPT or coming from Google search are not quite right. And how do you know if you are asking the questions right? You kind of need to know what the answer should be. So the outcome of the search result in ChatGPT, you need to know whether it's nonsense or it is right. Okay. So I've seen in the past the student kind of provide the same solutions that are incorrect. And that's how I figured out. You guys probably do Google search and ChatGPT. Yeah. So you still want to study to make sure that ChatGPT is telling you the right thing or nonsense. It's after all AI, right? It definitely helped with programming though. Yeah, Miguel, you know. Yeah, ChatGPT, you need to use it with caution. Is it F or FRQ? Yes, I actually, hey, spelled it out, Justin. MCFRQ. Okay. Yeah, so I think it's open web. So you can have your code for the assignments there, so that when it's during the exam, you can actually edit from the existing code you have. You see? Multiple choice. I see. Good question. There could be problem sets that are multiple choices. There could be problem sets that are, open answer, free response, and you need to kind of type or argue for your choice. Justin, go to the old exams. You will see that there are a variety of these problem sets. Some can be just, choosing from a few options. Some long answer. Some calculations. But for the first exam, there are probably not going to be calculations. But I don't know. Okay? Secret? Okay. I have not yet finished writing the exam, so I actually don't know. Okay? So there are going to be all kinds of forms. And and hey, the programming assignment related problems will all be, you logging into the PA workstation. And each of you will be given your own personal account, and you'll be working in your own personal account. Okay, so that will be very open. All right. So shall we go on with the lectures? Yeah. So we'll start from the last bit. Well, actually, not exactly last bit. So it's HTTP protocol. Last week we talked about what the architecture. Very simple. Client server. That's the communication model. Okay, we talk about the socket used. It's a TCP socket, and the server typically is on port 80. And we also talk about 3 different modes of maintaining such a socket, right? And one better than another gradually in order to reduce the response time. That is considered the key performance metric for HTTP or web browsing. And given a socket there, we can start send messages. And last week we ended with introducing a request message and what the format is, and the key line there called the request line. That is the first line in a HTTP request message. There's this thing called method, or it's essentially a command from the web browser to the server, asking the server to do things accordingly. Today, we'll start by introducing the second type of message, response message. Again, we'll start from an example. And you will see this video is 6 minutes long because response messages are typically longer. So the body part there will contain the web object that the request is asking for. And in those header lines, there are a lot more attributes and values that you could see the server want to tell the client. Okay, so here's the video, an example, long example of response message. Now, finally, the HTTP response message. Okay, the second type of messages in defining the HTTP protocol. You see here, generally, 3 parts. First, the status line. Second, the header lines. And the third, the data. So the entity body, so to speak, from here and down. Okay, and these are very similar to the header lines we see in request message. Each line, you see attribute and the value. Attribute and the value. Status line, 1, 2, 3. Again, 3 components. Let's go through each one of them as well in a bit more detail. In status line, first here, familiar. So the version of HTTP the server is implementing is the first component in the status line. Second, this is the status code. Okay. So in HTTP, it defines quite a number of these status codes. Each of these indicate a different condition. Okay. Some more related to the server, some more related to the object being requested. Okay. And for each of these status code, there's a status word being shown as well. That's the third component in the status line. So 200 here indicates okay, meaning the HTTP server is working well and the object you're looking for has been found. And it's going to come here in the body entity. Now, second part, the header lines. We see date. Yep, this is the date, time, the request is being filled, and this response is being generated. The server, this is an Apache server, version 2.0.52. Apache is one of the most commonly used web server implementation. Yeah, I think you heard about the other one, Nginx. So Nginx is certainly rising. Okay, it's not quite yet the most popular one. Well, let me clarify. By popularity, I meant the number of machines running a specific version of web servers. So Apache is still the most used web server. But if you count only the number of downloads recently, it might be Nginx. That's why you see I say that it's actually rising. Okay. So I think maybe in just a couple months, there will be more Nginx server than Apache servers. Last modified. Yeah, so this is to indicate when is the object you're downloading last modified. Oh, okay, it's a really long time ago. All right, ep8. What is this? This is actually, hey, for each version of the object that you are downloading, there comes also with a version number. So ep8 there is to indicate the version number. Nowadays, as you see, the HTTP protocol is not used only for downloading purpose. It can also be used for uploading. If there are multiple users there using different web browsers trying to upload the file, for example, pollys and Caleb, the TA, tries to upload and override the grades Excel file, then you might have a consistency problem there. So the number here is to break time, to make sure that a newer version does not override an older version or something like that, to resolve conflicts, so to speak. And accept range. Yeah, yep. So, you know what? Earlier when I mentioned the head comment in the HTTP request message, right? So when you send such a comment in the HTTP request message, the server responds with only the status line with the header lines, but without the data. Okay, so server there can actually tell the client, you know what? I'm a server. that allows you to request content in terms of bytes. So the client there seeing this can then send a request more officially instead of using the head command, using the real get command and request to download byte 0 to maybe 1023 or byte 0 to byte 100. Okay, so you could do a range request in a way. And the server's next header line, content length. This is to indicate the size of the file or the size of the object that you're downloading. So you see the file size of the object is one critical parameter. Okay? If you're implementing a web server, you need to know a way to find out what the file size is or the object size is. Okay, so size is a bit messy. Let me clear the markups. Keep alive. Oh, good. This web server implements persistent connection. Okay, and so it indicates timeout interval is 10 and maximum 10 requests. So this is a persistent connection, but in the connection, it only accepts up to 100 requests. All right, so if it's more than 100, then you will force close. The server will force close the connection. So connection, keep alive. Content type, yeah, just like the client size header line we see. Yeah, the client accepts content of a certain format. Here, okay, this is to indicate the object the client is asking for, which format it is. And we see this is text-based HTML file and it's coded in ISO ep8. Right? And empty line, indicating this is the end of the header lines. Right after the empty line, the data goes here. If it's an HTML file, then hey, text starting from here. Okay, the first file. So this is an example of HTTP response message. You see the structure is very much like the HTTP request messages. All right, so that's a long example you see. The next video is just to introduce more of these status code and the status word corresponding to these status code. And so this will be the, we talked about messages. We define how many different types of messages we want to send when we are defining an application layer protocol. We define the message format. We also define the syntax and the semantics. Okay, the status code and the corresponding status words. Okay. So here's the short video sharing more of these status codes and status words. Next is just to share a bit more. HTTP response messages status code. We've seen earlier in the example 200 OK. This is saying request is successful, object is already embedded. 301. That means the server is saying the object is moved to a new location specified later in this message. So sometimes when you run into a message like this, you see, oh, click here. That's going to take you somewhere else. It's a redirecting link. If you see status code 400, that means your HTTP request format is not quite correct. Bad request. 404, that means the object you're asking for is not found. 505, HTTP version not supported. So in case you're using a very, very, very old browser, or if you're contacting a server that's very, very old, and yet your browser is implementing something newer, then you might not be able to communicate. The server is going to tell you this. Sorry, 505. All right, so that takes us to quiz 11. So let me go to the whiteboard. Oh, there we go. Okay, so those who answer quiz 10 on behalf of the team, okay, we'll see that quiz 11 is very similar to quiz 10, right? So in quiz 10, you're asked about the content of an HTTP request message. This time, okay, Polly sniffed an HTTP reply. Okay, or HTTP response message, and here's what's shown, okay, from the sniffer. Okay, so given that, Q1 asks, was the document found successfully? Q2, how many bytes are there in the document being requested? What are the first 5 characters of the document? All right. Should be very straightforward. I'm going to take the first responder, first solver. Okay, so let's go to the score. Channel W5, quiz 11, guys. For this quiz, you have 3 minutes to think or identify why, and 1 minute to type it up. And that's start counting. All right, so hey, quite obvious, isn't it? Okay, okay. Yeah. Yeah, some might consider the first 5 characters in the showing part of the web object being the content. I see. Okay. That explains why. But yeah, but that content equal, that is actually to describe the format or the encoding mechanism of the content. Yeah, but I see what you're saying. Okay, you look into looking to the content of the response. Okay, and I ask the first 5 characters of the content. Yeah, but it's okay. So this is the exercise. The key point here for quiz 10 and 11 is, hey guys, HTTP messages, if it's just using regular TCP connection to send, it's plain text. One can sniff and see what's going on and what the people are asking for, what information the people are asking for. Okay, it's plain text. All right. Good, so that's return and continue. So in this topic, Polly is going to demonstrate, okay, pretending to be a web browser and sending a request to a real web server and see how the web server responds. Okay, first video, a little bit just 2 minutes, slightly more than 2 minutes. That is to tell you the setup of the demo. So what I will show you in the demo coming next is to do this. Telnet to the favorite web server here, and we're going to use this machine here that the textbook author has set up for us. So we'll telnet to gaia.cs.umass.edu at port 80. Okay, what it does is to open the TCP connection to port 80 where there's a server already running, a web server already running. And anything typed in will be sent to port 80 at this guy. Okay. So Telnet is a remote logging application, just like SSH or RSH, if you know what it is. It's another remote logging command for native Unix users. All right, so Telnet is very, very old. Many operating systems probably doesn't support it anymore. But I've already installed it on my Mac, so we're going to show that in a little bit. Now, once we telnet to the web server, and we'll type up some things. Okay, let's try typing this. Get path name and file name as the argument for the get command, and then the version of the web browser. So we'll be pretending that the telnet here is a HTTP 1.1 client, and host gaia.cs.umass.edu. Right, so header line. So essentially, we are trying to do a human web browser, okay, by typing online right here an HTTP request message. So once we are done with this, we hit return, okay, and then we hit return again. Needs to have a what? A \r\n here in order to complete the HTTP request. All right, so the whole thing is going to be like this. And yeah, we'll see what pops up in return, what the server there at umass.edu sends back. Okay, let's not sniff the traffic. Let's just look at the response coming out of the Telnet program. All right, so let's switch to the demo mode. Okay, now the terminal showing the demo. All right, let's telnet to gaia.cs.umass.edu at port 80. All right, connect it to gaia.cs.umass.edu. Now let's pretend to be a web browser. Get. Oh, wow, that's pretty long. The path and file, pretty long. Let's copy it from the sides. And over here and print. All right. And then host poly.ntu.edu. How about that? All right. And one more empty line to indicate this is the end of the header lines. There we go. Wow, it's returning a lot of things. Scroll back, and scroll back. Wow, very long in fact. But it looks like it's an HTML file, right? It's an HTML file. This is a hyperlink to an text HTML file. Okay, let me scroll a bit faster. I don't know how long this is. Oh, there we are. Yeah, so we typed up this line here. Okay, and we also say we are host poly.ntu.edu.tw and an empty line and then return again. The whole message gets out to the web server at gaia.cs.umass.edu, and the web server returns this http://11 to the 200. Okay, and header lines number 1, the date. Header line number 2, the server. Oh, it's an Apache server. And X powered by PHP. I see. Content length, content types. And hey, empty line to indicate this is the end of the header lines. And starting from here, the real body. Okay. So we get the output of calling this PHP query at this path. Let's see, interactive problems, computer networking, a top-down approach. Oh, okay. So this looks like the main page of all these interactive exercises that we see every now and then on the slides. All right. So there, essentially very text-based interaction between the client and the server. as human beings, we could also do it right here, right now, online as a web browser. All right. And I think let me just go back a little bit here. You see here, 200 is a very classic example of, hey, the syntax defined in an application layer protocol. In HTTP, to be exact, 200 is to indicate OK. So OK here is just to say it explicitly, the semantic of 200. Right? So that concludes the messages format, semantics, and syntax of HTTP. All right. So starting from this point on, it's still related to HTTP, but it's actually additional mechanisms to help improving the experience of using, experience of doing web browsing. Now, the first thing we want to talk about is called cookie. Okay. I'm sure that this term is familiar to most of you, because there are many websites nowadays. When we go, we are prompted whether you want to accept cookies from this website. Okay, so if you are wondering what that means and what the consequences are, yeah, you come to the right place. So this first video talks about the mechanism of cookie. Okay, recall HTTP by itself is stateless, which means the server does not store anything about the client, about the user. So you might browse a certain website multiple times, but the server does not store anything about you. But cookie is a mechanism to allow the server to track, okay, what you've been doing. That can be good. That can also be bad. But let's figure out how it works first. Okay, so this is the mechanism of cookie, 6 minutes. Next, cookies. Yeah. Many websites these days will try to prompt you to set up cookies before they allow you to visit the website further. So it's very, very relevant to our everyday life. Let's see how it works. Okay. First thing is, the cookie setup process is always initiated from the website. So meaning from the web server that your web browser is requesting objects from. So web server there is going to send a message to the web browser carrying a special header line. Okay, it's the cookie setup special line. And the web browser there, upon receiving such a message, it's going to generate, okay, a corresponding message if you click OK to insert cookie. And that message is going to carry, again, a special header line saying cookie OK. All right, so exchange of messages between cookie setter and cookie allower. Now, when you say, OK, I will allow setting of the cookie, your browser is going to add an entry to the special cookie file on your local disk. Okay. So that is exactly what's expressed here in the special cookie setup line. And when the server receives the message allowing cookies, server would then add a special entry as well to the backend database. And that entry set up here and here will actually map to each other, allowing the server to identify who you are and when have you visited the website last time. Okay. Let's use an example to explain. It will work slightly better. Let's say Susan always accesses internet from her PC. And she's visiting a specific e-commerce site the first time. In the initial HTTP request, okay, that arriving at the server, the site will then create a unique ID, okay, and that will be an entry being added to the backend database. Right? So that ID is going to be carried. Okay, in the message, the site sends back to Susan. So that's going to be set cookie and then the number created here. All right. So local hard disk you have there, or Susan has there, will have that entry, okay, set up in the cookie file. So this will go back to the server, okay, carrying also that special ID that Susan has already allowed to set up. And then at this point in time, the server would finally enter the entry to the backend database. So that's the way it works. Let me illustrate, okay, and so that you know clearly what's going on. Client, server, or Susan, Amazon.com. Okay. Now, at the client side, you have this special cookie file, and it's managed by the web browser. And you might have clicked OK to eBay. So eBay has already set up a cookie entry carrying unique ID ep8 server here has a local disk as well, it's maintained more as a backend database instead of just a simple file. Right? So, but when you visit the website, Amazon.com the first time, you send an HTTP request message. Now, of course, you have not yet been in Amazon before, so there's no entry for the Amazon website. Okay, so in your initial HTTP request message, there's not going to be any cookie special header lines. All right. So when Amazon.com here receives HTTP requests, of course, it will try to grab the objects that you're looking for and try to generate the HTTP response with it. But in the meantime, it will be creating an ID, okay, for this particular user, okay, and add that to the database. And in the response, it carries the web object that you're looking for, but it also carries the special header line, the set cookie line. Okay? And hey, see the ID created is carried over through the HTTP response message back to the user. So web browser here sets up one extra entry saying, hey, for Amazon, the website, use ID 1678. So for the subsequent visit, subsequent browsing, all the HTTP request messages is going to carry the cookie OK and I am a user 167A header line, right? So here the server, of course, will be generating the web objects, generating the HTTP response message that you're requesting with the request message. So response message. But the response message might also contain additional content, okay? Server there could be seeing your browsing history a couple clicks back and discover that, hey, you might be looking for a specific item, okay? And then recommend potentially items you'll be interested, okay? So that might also be part of the response messages. So showing the items you are looking into buying as well as related products. Okay, so for example, if you're looking to purchase a phone, then the website might be recommending a phone case, okay, or a number of phone cases. So what's amazing there is 1 week later, okay, when you come back and try to purchase something from Amazon again, okay, the first request message you'll be sending will already be carrying the cookie entry. Okay, so once you have it set up locally on your cache file, on your cookie file, for all the subsequent HTTP requests, it's going to by default carrying the cookies. Amazon here will know, yeah. So over time, the server will know probably your profession, probably your income level, things like that. Okay, so that's why it gives people a certain creep about setting up cookies, and you might be warned, be careful about setting up cookies there. All right, so that's the cookie mechanism. There was a question from Sophia. What if we delete the cookies or use the incognito mode? So yeah, I think deleting the cookies will prevent the website from knowing who you are next time. Okay, but between the deletes, they can still infer that you are some user, and they might still be able to track between the deletes who you are. Incognito mode is actually a lot more advanced. So incognito mode also says that the web browser will not track who you are or track your browsing history. Yeah, so even the web browser is also stateless. Okay, it's interesting. Yeah, but either way, it's trying to protect your privacy. Yeah. All right. So yeah. So the servers might learn a lot about you. Hey, the web browser might also learn a lot about you. And so the companies selling these web browsers to you, or you download to install, they can still collect information about you. Okay, think that way. Now, let's talk a little bit more about the upside and downside of using cookies. Some of you might see better that, hey, it helps, right? You don't have to log in again and again. But then, yeah, yeah, Amazon do know a lot about you. So the trade-offs of using cookie. Now let's discuss cookies a bit more. We're going to talk about the trade-offs of using cookies. First, the cookies, from a business perspective, from a website's perspective, is actually quite convenient. So you see, you can authorize the users quite easily, okay, by looking at the ID in the cookie header line. Tracking the shopping carts as long as the ID is the same, right? This is items purchased from the same user. You can recommend items so that the users will go, wow, cool, that is exactly what I was looking for next, right? If the user is purchasing a phone and the website suggests purchasing of a phone case. Yeah, and browsing emails, yeah, you will not want to try to log in and type up password again and again. You want to be able to maintain that email reading session, email sending session over time and log in just once. How? Very nicely through the cookie line in the HTTP request. Okay, quite convenient. Okay, otherwise, you guys, including Polly, when I read my Gmail, I have to log in again and again and again. There's no way we could live like that. Right? So convenience. But on the downside, those websites will be able to learn a lot about you. Okay? So you store emails, that's pretty much your personal life. You store your purchases there, that's pretty much also your personal life. Okay? So over a long time, you can imagine Google, Amazon, Facebook, all these major websites, they know a hell of a lot about you. That's why people are freaked out so much about these big sites, okay? Allowing them to set up cookies, allowing them to store information about you, okay? So downside, privacy. Okay. Now, another perspective is more technical, keeping states. Now you see, hey, there's ID on the local cookie file. There's ID stored at the server side, the backend database. So server and clients are now storing states of each other, about each other. But some of you might go, hey, wait a minute. Didn't we talk about HTTP being a stateless protocol? And what's nice about stateless protocol is that, hey, none of the endpoints need to store anything about each other. Okay? No storage requirement. And you don't have this problem where, hey, if the connection between the client and server is broken, and you might have these inconsistencies in the states they maintain for each other, right? You have to reconcile and resolve conflicts. And that is actually a very, very hard problem, okay? Who do you trust more, the server or the client? Okay, sometimes it's a bit hard to say, okay? So cookies here, you're seeing is, in a way, a hacking HTTP such that we can maintain states, because HTTP was not designed in the first place to maintain states. But then now with the cookies, we have this issue potentially between the client's cookie file and the server's backend database. What if, the entry is inconsistent? Then you might have an issue as well. So trade-off in terms of usage, okay, in terms of privacy concern. Trade-off in terms of technical difficulties maintaining the states. All right, so that was cookies. And the next big topic related to HTTP is called caching. Okay, so caching is a term referring to temporary storage for things that you might need, again, quickly. Okay, so there are two kinds of cache. One is local cache. That means you keep a copy of the content locally on the hard disk where you are starting the web browser. The other is called web cache, where you set up a machine, okay, in between the client and the server of a HTTP connection. That special machine there is called a proxy server. You store these web objects temporarily on that server, okay, and hopefully that a bunch of users connected to the web proxy, okay, to browse the web can benefit from downloading object quickly. Okay, so that is web cache. So these will be the topics we will start talking about tomorrow morning. Okay. With that said, hey guys, if you have not yet completed quiz 11, go on and use the time to complete it. And those who have already done so, yeah, congrats. You're done with quiz 11. There are 2 more quizzes coming up tomorrow. Okay, one of the quizzes is open problem. So you want to pay attention to the lectures tomorrow Many of the questions in the exams will also appear tomorrow morning, or the content for the in order to answer the questions will appear tomorrow morning. So I'll see you tomorrow morning. And this is all for today. Okay, bye. Yeah, so hey guys, bye. So just to answer Jiabao's question, yeah, how long the cookies should exist to maintain logging state? That's a very good question. Every website maintain different policies. And I think so I actually am not quite sure what Facebook's policy is. A lot of times after you log in, they might prompt you and ask whether you want to keep the connection, keep yourself logged in. Okay, so that's usually the mechanism for the cookies to remain effective if you come back to visit the same website again. So how long? That is a very good question. I think it depends on how long you feel you're comfortable allowing that. So Jiabao, if you are browsing the web using your own laptop and only your own laptop or your own PC, it's okay to allow the cookies for longer, because it's hard for other people to access your machine. Therefore, they don't have your cookies. So they won't be able to pretend they are you and log into Facebook and then start bashing people. But if you use public computers for social network applications, then every time you log in, you log out, and you do not allow setup of cookies. Okay, that is the best practice these days. Okay, so if you only access the internet from your personal machines, it might be okay to allow the cookies to go longer. But if not, if this is other machines, just disallowed, okay, using of cookies. And hey, personally, the best advice for you guys is just avoid using public machines or public Wi-Fi that does not have encryptions. Okay? I hope that I answered your question, Jiabao. Okay, bye. Okay, see you.